I am in my office in Poland at Vistula University. So maybe just I can give you brief information about university and myself. Vistula University, that is located in Poland, in Warsaw, capital city. And we have a group of universities and we have students from all around the world. So it's like one of the most internationalized university in Poland. There are around 15,000 students, I can say, more or less 15,000. Quite a lot of students are coming from 105 different countries all around the world. And one of my students from South Africa just told me that, so then he has some colleagues in Tehran University, and so we can just cooperate, or you can just give us some seminar. So my specialty is about, let's start from the like higher to lower, information retrieval from their recommender systems. So recommender systems, especially for collaborative filtering, I can say that. So it's a kind of data science, data mining, we can call these names also. But when we just do some seminar here, it's not going to be so long. In that seminar, you are just going to see how is it working, and then what can we do in our life while we are just using it. Okay, so then if you don't mind, so I'm just going to share my screen page, and I'm just going to start my presentation. Now, can you see my screen now? You can see it, right?
Yes.
Okay, super then. So, okay. So, developing recommender systems for different user requirements. This is the title. So then my name is, as I mentioned, like at the end of the day, Senyurek. I'm from Vistula University in Poland. And my Instagram account is Senyurek as well. Also Facebook, also LinkedIn, also all other accounts. I'm using my name and surname everywhere. You're more than welcome if you want to follow or if you want to ask some questions in the future. So first of all, I just would like to continue with the definition. What is recommender system? In our real life, for example, you are just going to abroad. Let's say you are going to come to Poland, or I will come to Tehran University, Iran. And what are we going to do? For the first time that you are going to come here, so then you know nothing about that country, that city. So what is your first intention to do? You are just going to try to find someone who visited there, and you are going to ask, what do you recommend for me when I go to Poland? Or when I come to Iran, so where shall I go and visit? What shall I eat? What is the best food that I must try when I come there? So I'm just asking these questions to my colleagues, to the one who was there, who is from Iran, or who just go and visited in that country. So then these questions, like similar questions, where shall I visit? Which hotel is the good one? Will I like that cuisine, that foods? What do you think about it? So who are you going to ask this? Are you going to ask these questions to anyone on the street, or someone who knows better, like family members, like friends, like the one who is in the same taste that you have? That would be better. For example, if I'm from Poland and I come to Iran, then for example, I may like that food, or I may not like. Who knows? My Polish friends may know my taste already. You got my point. So then I'm just asking recommender, some recommendation from my colleagues who knows my taste already about food, about hotel, about cinema, or whatever is available there. So then from that point of view, we can just say a recommender system has like two main two main structure, let's say, personalized and non-personalized. We are going to focus on personalized soon, but the non-personalized means that people people, ordinary people, whoever are they, doesn't matter, from Poland, from Iran, from wherever. So they just visited some place, they just taste something, and they just voted. So then more people just voted, and you can see on the corner here saying that 9.1 or 8.9. This is the taste of like people. There is no relation between me and those people. This is like general vote. So that's why it's not personalized to me. It is for everybody. So then it seems if I just go to Poland, if I go to Poland or if I come to Iran, so then that company, that restaurant is one of the good one, let's say. It seems according to the population, according to public, all right? Maybe I like it, maybe I don't like it, but at the end of the day, in general, it is like 9.1 is good. So this is not non-personalized. When we come to the questions, it can be anything, right? For example, what book is good for me from bookstore that I can buy? So what kind of document is good for the database course, for example? This is also another recommendation is needed. So is that movie is good for me or not? Even this question might be asked. You know, there are plenty of the such kind of websites that you are just going to ask your friends, right? Anyway, so here from, I think, Amazon that I took this photo, if I'm not wrong. So you also see some advert at the very bottom of the page in general. When you buy some book, what you can see there, customers who bought items that you bought already bought the following ones as well. Generally, as you have seen, generally it's just valuable for you. For example, if you just search for the game book, according to this picture that I'm showing now, its system is advising you, recommending you, you can buy this Mathematics for 3D game. Why? Because previous time, some other people who bought such book that you bought, they also bought this following one. You got my point. This is also happens at the moment in the market, in the industry, for the websites, or as I mentioned, like Amazon, for example. When you buy something, or if you just intend to look at something, the one who looked this bought the other one as well. So you remember these kind of things, right, in the system. And as you see, that system is very clever, intelligent. Okay, so then there are plenty of the examples in our real life. So when we continue, am I fast or good enough? Shall I make it slower or is it good? Good? Good. There is a message I must just... Okay, good. What do we do in these cases? So, as I just mentioned before, in these cases, we are just asking our friends, someone who have to get some opinion from them. What else? This is the important part, recommender systems that we are just asking. For example, I think maybe you are just member of Netflix or Disney Plus or some other materials in the website. It's very common here. And when you just enter that movie website, you are just asking, will I like such and such movie? Will I like such and such music, for example, from Spotify, from your phone? If you are just listening, you are just going to say that, will I like this movie? Will I like this music or whatever? So then you are just going to ask to the system. When you ask the system, of course, we should use we should answer one of the important things, how this system works. So then we are just going to focus on now. It is going to use customers, in other words, users' preferences. So, in other words, before system advise me something, recommends me something, system should know who I am, and system should know what do I like, what is my preferences. Okay, this is the important part. And that's why these definitions are becoming important. In summary, you can just read through properly there. Recommender systems are just giving some prediction. They cannot say that 100%, but prediction only. Depending on your previous preference, previous rating, previous test, previous value that you give into system. And to do that, of course, one important issue is filtering. Filtering depending on your interests, and collaborative filtering depending on your interest and combination of the other people, other users interested. So then the one who is similar taste that you have from the system are just giving you some prediction. We are just going to come to this topic now. And I just have to mention that there are different types of recommender systems. So generally it's just based on filtering. This is just part of it, I can say that. Collaborative filtering is the most common one. In the scientific area, you can find a lot of document, a lot of article about it. There are not that much that collaborative filtering much, but there are still some documents about the articles about the content-based filtering. Also, there is another one, knowledge-based filtering. And recently, a few years back, I can say that some other recommender system filterings just appeared. Social media filtering, for example, is common at the moment. Graph-based knowledge filtering is common at the moment, and combination of any one of them as a hybrid model is also available for the recommender system. And collaborative filtering system, it is just a user-based approach, so it's for the user similarities that it's looking for. I'm busy with it at the moment, and or item-based approach is just becoming more valuable depending on what kind of data set that you are using, or combination of those two, like a hybrid approach is possible to use it. Of course, in this presentation, in this seminar, I'm not going to go so much details about each one of them, but I'm just trying to give you like brief idea. How does it work? Think about it. So, for example, for let's say Netflix, there are, I don't know how many, but hundreds or thousands, I can say that movies are there, and million people are just having an account there, and they are all watching the movies, and you have very big data set. I just like such and such movie, I give plus. I just like another movie, I give another plus for that one. The people who gives the similar taste for those movies, for the third movie, system may just recommend something to me, and it's just done very easily. And there are different approaches for the recommender system. One of them is memory-based approach. It is just checking whole data in the data set. So then it is very good when accurate result, accurate prediction it gives when you just approach with the memory based. So then when you just take all data in the data set, okay, just try to please think like two big data sets. So lots of movies, lots of users. Change it, lots of books, lots of people. Change it, lots of television program and lots of people who are watching. So then it's very big data set and you are just checking. Think about it. So then please, and it's just memory based. So it is just taking your time because you have to check all entire data set. But because you are checking all entire data set, so it's going to give you proper and correct, more correct prediction result. When it comes to model-based approach, it's the second version. What is that? So from big data set, you are choosing like part of it, you are not taking whole data set because very huge. If you are choosing like part of it, so which means that you are going to focus on sample data, in other words, let's say this way. Prediction is not as accurate as memory based, but it is much quicker. Depending on which one is more important for you, if both of them are important, then hybrid approach is going to be much better for you to choose. So, you know, in the lectures as well. So then for the first few hours or first few lectures is just more theoretical to prepare the base, later on practical. So we are going to do some practice as well together. I'm going to show you one by one, but now it's like basic stuff. So after that, we are just going to continue the others. So here the systems, recommender system types, as just showed you before. Content-based filtering, I just mentioned already, you may remember. What is it? It is generally recommends the item based on the content. So for example, I know an actor which is very famous, let's say Will Smith, for example. If I like his movies and comedy of this this gentleman, and when I just ask to the recommender system, it just advises me Will Smith's comedy movies in general. And then similar to this content, if in the database there are some other movies, even some paragraph can be there, information about the movies. System is just recommending to me by using the content-based filtering. It is used for the, it might be used for example, Twitter. Why? Because similar contents from the Twitter can be just filtered, and then maybe just some idea may appear, raise up. Example I just give you, or from Instagram or from Facebook, whatever. So it just from name you can understand that generally it checks the content of the data. Let's see. The second one, the other one is collaborative filtering. What is collaborative filtering? It is just a different way. Either it may have like numeric data, which means that for each product, users are just giving some numbers, can be continuous number or can be discrete numbers from 0 to 5, or from 0 to 10, or from 1 to 10. It can be like numeric or discrete or continuous value, or there might be a possibility to use like or dislike. What does it mean? For example, at the moment it's very famous in the internet. If you click, it is called like. If you don't click, it is called dislike. For a button, for a picture, for something. For a movie, if you click play button, you liked it. If you don't click play button, you don't like it. If you watch a few seconds in YouTube channel, for example, for something, if you just start to watch, let's say 10 seconds, so you like it. If you don't watch it for 10 seconds, less than 10 seconds, you dislike it. You see, like shortly for computer engineers or for computer-based people, it's called like true or false issue. That threshold is depending on the person who is doing the algorithm, as I mentioned. Maybe you may know when you start to watch or when you start to search in the internet for some companies, not at the same time, maybe 15 seconds later or 30 seconds later, a pop-up menu appears to help you by the artificial intelligence. Sometimes real person is saying that, how can I help you? Why not at the same time? Because maybe you just, by mistake, you went there. You want to go somewhere else. Oh, no, I'm just interested with this company. So then pop-up menu just appears there to be able to talk with you. And of course, combination of any one of those can be hybrid model. I'm just not going into details. So let's come to the next presentation. Here is the nice picture. Look at the person on the right hand side. There is a guy who is not cycling, the other one. That one, he is just ordering a pizza and buying a pizza. Next to pizza, he is buying a salad, as you may see. And as you have seen there, so he just bought a Coke as well. So it's a person who just went to a pizza shop and buy a pizza with the, I think mushroom is there, mushroom, some other mince balls there. Anyway, that pizza he just ordered, and salad he ordered, and he just ordered a Coke. And that the other person who is just cycling at the moment, he went to same Pizza Hut, same pizza shop, for example. He ordered pizza and salad. You see, By ordering pizza and salad, as you may see from the picture, these two guys are almost similar because it's like drinking time at the moment. The system looks at these first two materials, first two food, and it's not only pizza, it's pizza with mushroom, very same as the other one, and salad with tomato or whatever, very same as the other one. So system recommends that, look, there was a person who was similar to you. He ordered Coke before, and I believe you will also like Coke because you like mushroom pizza. He also liked mushroom pizza. You like tomato salad. He also liked tomato salad. Most probably you are going to like Coke as well. So that's why system recommends, please have a Coke if you want, of course. You got my point. It's a just recommendation by the system, by looking at these two gentlemen on the picture. When it comes to tasks, so how are we going to work in the system? First of all, because in pizza shop, there are not only two people are going there. There are like 100,000 people there. When we make a look at the collaborative filtering systems, so there are two possibilities. First of all, we can just give a prediction. We can give an advice for only one signal item, especially this one. Will I like this movie? For example, Spider-Man 5, 6, or whatever it's called. I don't know. I'm not just good movie person. Anyway, so Spider-Man. If you ask to the system, will I like it? Then system is going to predict, say that most probably 70% you are going to like it. 5% you will like it. In other words, you will not like it. Something like this. For one single item, we can give you prediction. Secondly, again, by looking at my previous taste, top N, top 5, top 6, top 10, top 100, top 20 recommendation, which means that we know who you are as a system. We know who you are because you are my customer already, and you did vote lots of movies. You did vote for lots of books. You did vote for lots of musics. I know who you are, and I recommend you as a system. I'm talking about 10 musics that you can listen and you will like them. The most one is the first one, the 10th one is that one. For example, like this, you can recommend top N recommendations. These are just two approaches, two functionalities, let's say. You can do it. Steps. Let us just learn the steps now. After that, we will do some practice. What are they? Is it okay so far? Is everybody okay? So then it's just boring or not? No. Yes, good. Yes, good. Boring or not? When you say yes, yes, boring or not? Okay, good. Let's continue. Yes, there is a website. The question is coming. Like, for example, Spotify. Spotify is one of the most common one, which recommends musics, for example. Okay. So let's continue. Especially smartphones just available for this kind of stuff. But of course, there are some other things as well. Let's continue to our presentation. Here, collaborative filtering systems basically consist of 3 steps. Okay, all steps we will do step by step. First step. First of all, similarity. I just told you that there were 2 customers there. One of them is cycling, the other one is just running. So then system said that because we just have seen the picture already, 2 of them are similar, right? But here we should do some calculations for the similarity. Calculation of similarity for 2 entities is important, and of course we need mathematics for that one. After we find the similar people or similar item, whatever, in the system, one by one, we are going to choose the neighbors who are most similar, let's say this way, closest one, and after that, producing the prediction. Okay, the chat area is open. Even if you want, you can there is a question at the moment. Normally face-to-face is much easier, but here is the question. The criteria is size and color. According to size and color, there are two criteria. How much percent B, C, D stars are similar to A? This is the question. How much percent? For example, B, how much percent is similar to A? C, how much percent is similar to A? D, how much percent is similar to A? We are just comparing with A, all of them. Let's say this is our data set. A is the first item. The other three, we are going to predict and find the similarities. Very good. Thank you very much for your answer. As you see, our criteria is size and color. According to size, B is exactly the same as A, but the color is different. So then 50% is similar. And C is 100%. And D is color is correct, same, but the size is smaller. So again, 50%. As you see, this is my criteria. I call this similarity criteria is EDIPS criteria. All right. Like this, there are some different similarity metrics in the science. Recently, I read an article. It was 76 different similarity metrics. Some articles just playing with that. I'm not playing, of course, doing experiments with not 76 of them, but 13 of them, 46 of them, to compare which one is better, which one is not better. How do I mean? What do I mean? The different similarity metrics. At the end of the day, you can just say that they are similar or not. If you have your criteria, for example, only two, size and color, you just said like 50%, 100%, and 50% another one. If you would add here, let's say angles, or let's say the size of the thickness, for example, you see, if you just change the criteria, so then the similarity is going to change. So yes, as you mentioned, these are the criteria that you have done, and then similarity estimations for the pictures. When it comes to the items, when it comes to the people who are here at the moment, in the middle there is a person that's, let's say, active user. It's called like this, active user, and the other 6 people around him are the people who are similar to that guy. And as you see in the system, for that guy, it looks that we didn't look at the gender for the similarity. Why? Because the most similar person, according to their taste or according that they love, is that lady on the left-hand side at the bottom, 0.82%. They are similar, right? And the least one is on top, that white shirt is 0.21%. You see? So from here, there are 6 people. And if you put in the picture, here this way in the graph version, and you can see active user has some distance. There are distance between them. And you are going to choose the most similar one, and you will decide as a threshold. Let's say most similar 4 people, most similar 3 people, most similar 10 people, or 100 people, whatever. So then depending on your threshold, you are just going to put, we call it as K value. We are just going to select the neighbors. Why we are selecting neighbors? Because we are going to check our neighbor's taste, and we are going to have a prediction depending on those neighbors. All right. If we use entire data set as our neighbors, so then we are going to have trouble because the data is very big and it's difficult to make calculations. And the last step is coming, which is prediction estimation. Now I'm going to give you some time. Please tell me, you can write or say in words, what can be the active user's target item. So this is very small data set. Think about like bigger one. How does it work? We are just going to make it. Here, look at here. We have 6 books in our market store, and Bob, Charlie, David, Martin, Kate are the customers, previous customers, and you are the active user. And for the book 1, everybody just voted, you gave 5. For book 2, everybody just voted, you gave 7. You got all the points there. Question: I'm asking to the system now, recommendation system now. Can you tell me please, for book 6, am I going to like it or dislike it? Am I going to give it a good point or not? Please predict. Please look at there and then tell me what you think. Is good. Point, as a point, how much point you can give for that? 6. Okay. Now, the question is, most probably because you look like as an active user, you felt that you look like David, right? Probably because of it. Look at the David, please. It's giving the book tastes. I mean, book 1, 2, 3, 4, 5, exactly same as yours. Because he gave 6, you felt that you are going to give 6. But look at Kate, please. Also, she just gave very same grades that you gave, right? Very same values. Why not 8? Why did you give 6? System should give you some prediction. Let's see. Look at those votes. It is similar to those 2 people. Well done. Very well done, Mr. Erfan. And you can see both of them are exactly same as yours, right? So then, but when it comes to 6, book 6, David gave 6, Kate gave 8, right? And most probably, as Erfan mentioned, it's going to be 2 neighbors, and the most accurate one, these are the most similar users, and the most accurate one, 6 plus 8 divided by 2, which is arithmetical average, that is equal to, as you see here, 7. That's the most accurate one. It's most probably. Of course, I may be similar to David and give 6. I may be similar to Kate and give 8. Even I may like more than them and give 9. Or even I may dislike more less than the others and give 5. It's possible. But most likely, because of my previous taste, most likely I'm going to give either 6 or 7 or 8 on this area. At the end of the day, it's just more than 5 if it is out of 10. Most probably I'm going to like it. Okay? Without reading this system, without reading this book, system just give me a prediction. But there's a but issue now. Because in this data set, for the first books, we have exactly the same data. But if you have such vote, what will you do? That shows that Bob, for example, for book 1, he didn't read, but I read. I am Alice at the moment. And David also didn't read, but I read. And no one else in the system gave 4 other than me, as you see, for the book 1. When it comes to book 2, okay, Charlie is giving the same grade that I gave. And Charlie, again, when you look at the number 5, is giving the same grade that I give for 3. However, Charlie didn't like the book that I like at the beginning. I gave 4, he gave 2. You got my point. There is no one who gives exactly the same as mine. Are you with me? Okay, do you have an idea? How much point? A few idea, let me get it, and then let us do calculations and let us see who is going to be the most accurate, more accurate numbers. Okay, tell the result. Let's see. Just write the result there, and I can just later on I will say the winner, who is the closest one. Okay, while you are writing, I can just continue. Average of Martin and Kate, it says 3.5 that you sent, probably. Okay, let's continue now. So, as an example, here, the row represents, as you see, the users, column represents the items. We call it like user item matrix. From your knowledge of mathematics, of course, you may understand user item or item user matrix. For this matrix, we have rows and columns. And give me a second, please, because sun is starting to disturb to camera. I think that will be much better. Is it better? I don't know. Anyway, let's continue now. Here, when we talk about the item that we are looking for, we are called active user, and the item that we are just going to give vote is going to be target item. Okay. From the active user, the target item, we are going to get the prediction. How does it work? I will try to make it slowly. Later on, internally, with your classmates, with your friends, you can just play with it. You can do some calculations, which is very nice. Of course, I'm saying that with your friends, but you can find the data sets from the internet already, and you can just improve it. How does it work? First of all, for each one of them, we are just going to choose one of the, we are going to find the mean values, average of the people. It is needed. Why it is needed? Because you may know from some of your teachers as well. You call it Mr. X, who is giving the lowest grade is 7 and maximum is 10 out of 10. And Mr. Y is giving highest grade is 7 and he gives you 5. So which means that from Mr. X, when you get 10, you are happy. From Mr. Y, when you get 7, you are happy. You got my point. At the end of the day, they are teacher, and at the end of the day, they are just giving you pass mark. But the highest values are different for their point of view. You got my point, right? So, what are we going to do now? We are just going to make all of them balance in the same level. So, first thing, we are just going to calculate the average of each votes. Mr. Bob, for example, 3 plus 4 plus 1 plus 2 divided by 4, overall average 2.5. Like this, Charlie 2.2, David 3.5. You see, like these are the average, including yourself. So you cannot say that because of the average, I am more similar to David, or more similar to Kate, or more similar to Martin. You see? So then you are not similar to any one of them, or you are similar to all of them. So then first step, we just calculate the mean value. Second step, mean value is just the one that we calculate on the right hand side. You can see on the table here. Okay. And the second issue, from the system, we are just going to compute the standard deviation. Standard deviation is like mathematical term. You may know that, or you can just find out from the internet easily. Standard deviation is calculated this way. How? From each value that you have, 3, 4, 1, 2 for Bob, minus mean value of his, 2.5, and square of it. 3 minus 2.5 square, plus 4.4 minus 2.5 square, like this. And at the end, after adding all those numbers, when you get the square root of it, 2.24 is the standard deviation of Bob. 2.61 is the standard deviation of Charlie. What is standard deviation? The difference between the numbers that they are using. Okay, in other words, like the deviation between numbers. You see, like 3.16 for Kate, and for Alice 1.66. You see how different the grading between the numbers. So if you don't mind, I'm just going to come back quickly. You can understand. Look at the values here. For C, there are some books like with 4 with high numbers, but for A, you are just more closer numbers to each other. So then that's why for A, between numbers, the deviation, the difference is not so big. For C is higher. For M, there is 5, also 1 in your numbers. You see, the lowest and the highest grade. So like this, when you do that standard deviation calculation, you see like these values are just appearing. What is that? Standard deviation. Next step, our data set, the original data set, should be converted to normalization. normalized. To normalize the data set, we are using deviation from mean. So which means that here, how am I going to do it? We will see. Look at here, item 6. What is this? Rating of Bob for item 6 was 2, right? It was given here 2. And what have we done? The Bob's average value was 2.5. He gave 2, but the mean value was 2.5. And 2 minus 2.5, which means that from the value that you give minus the mean value 2.5, result is minus 0.5. So like this way, 1 Bob's value, look, 1 Bob's value for item 5 minus 2.5, it becomes minus 1.5. And for item 4 minus 2.5, 1.5 is the plus 1.5 is the item 4. So what do? We just normalize from each cell value that is given by the user minus their average. So then we created normalized matrix of the data set. Okay? So here, the next step, I'm going to show you one definition and I will continue. What is definition? We are just going to calculate the weight. In other words, it's the similarities between each user to me, to active user. In other words, come back, we will just calculate how much similar Bob between how much weight, or what is the distance between those two? Charlie and Alice, David and Alice, Martin and we are just going to calculate each one of them one by one to see how far we are. And after that, we are going to choose some of them as a neighbor, which means that like 1 is the most similar one, the least similar one, or minus 1 is totally opposite. So then you can just find this way. And we are just going to calculate each user's value one by one. Let's continue now. You may remember that normalized data set, all the values are on the corner on top. And you can see that the standard deviation that we created. And after that, there is a like weighted calculation. How do we do that? Look at the Alice value, 0.75, 0.75 empty, minus 125, minus 0.25. And these values, together with Bob's, are up there. How are we going to do? One by one, for both of them are voted. For example, for one, item 1, here, item 1. That's why I don't use my vote here. Bob did give 0.5 for the item 2, and I have 0.75 for item 2. So then there is a correlation between those two. 0.75 multiplied by 0.5. For item 3, we don't know because we don't know each other. For item 4, 1.5, 1.25. You see? Minus 1.25, 1.5. We multiply minus 0.25 minus 1.5. We multiply, divide by what? Bob and Alice. 166 and 2.24, which is our standard deviation. And as a result, between Alice and Bob, the similarity is minus 30%. In other words, we are not similar, but we are opposing 30%. You got my point. So then this is calculated. Of course, now it's going to explain one by one what is what. Okay. And after that, I'm just going this part very quickly because at the end of the day, this is what I explained one by one already. Okay, maybe it's in video and then you can pause and check if it is correct or not. And at the end, we have this. I'm not going to go so much details for between Alice and Charlie. This same calculation has been done and 0.23 plus is more similar. One more time, 5, it is Alice and Martin, Alice and Kate. As you see here, the most similar person to Alice is, and the least similar is Bob here. You got the point, right? And the next step, what we are going to do, we are going to choose the neighbors. As I mentioned before, we are going to choose one of them as a neighbor, some neighbors that are K nearest neighbor or threshold points. So for us here in this project that we are doing, we choose K nearest neighbor. So you have remembered that we graph already, and our idea, at the end of the day, we can say it 4, we could say it 3, we could say it like 5, we could say it 2, whatever. So then from the highest to lowest, when you put in order, I can take care of issue. I will choose first 4 users as because they are the most similar ones. And Kate, Martin, David, and Charlie. In this order, they are my neighbors. Kate, Martin, David, and Charlie. They are my neighbors. For the prediction estimation, there are different evaluation criteria. For the prediction estimation, we can use similarity metric, one option rule. Maybe you may know from the statistics. It is called Pearson correlation. It's not going to do it like one by one by your hand, no problem. And here, what you can also do, you may be able to just use a computer, and with this way, this is the formula. 3.25, do you remember what was it? 3.25 is the average value of the Alice. 1.66 is standard deviation multiplied by all the values like 0.46, 0.23, like this. What are they? Let's come back. Here, these are the similarities. Plus, well, let's come back. These are the values that we are using for the multiplication. So that's why whatever to be able to use in the formula. Anyway, let's come back here. Correlation again. Sorry, to go back and come back. And the calculation has been done. All active users to target item vote is done. Mean value, standard deviation, and result 3.45. In other words, this is from the system is going to tell me that most probably you are going to give point for this item. Now this is my decision if I would like to read it or not read it. Okay, so these are like mathematical calculations. Of course, when you do for the 5 items, for 6 items, 5 people, that much time, 1 hour, if you spend, if you have like 100 movies and 1000 users, how much time do you need? Very long time. That's why you are not going to use pen and paper. You are going to use some software, and in your software you are going to put these formulas, calculations, to be able to find the result. It is real, and it is in the market industry they are using at the moment. And by using this way, they are just getting the correct prediction value. And of course, I have to just mention about the collection of data. How to collect 2 ways. One of them is like implicit. Clicking on it, watching for certain seconds. For the implicitly, generally, you cannot just see the votes, 3.5. You can see that like, dislike, watched, not watched. Okay, tick, not tick, something like this. In general, the value is 1 and 0. explicitly the question is coming. So then how much point you give? 5 point, 2 point, 3 point, 3.5, something like this. So then after those data collected, to give you some idea, I just put here some samples of data sets. Of course, there is a website is called Kaggle. There are plenty of the data sets that you can use. The thing is that you must focus on to make the tests data. User and item should be there. And in my research in general, I'm using movie lens, gesture jokes in general. Book crossing is also one of them. Each movie was old version. These are the number of users and number of items. And the number of rates are also written there. And here, as I told you, doing some calculations, there are 6,000 users. So the formula that we implemented for 5 people should be implemented for 6,000 based. If you are going to choose some model from there, it's going to be just less. Anyway, after that, what we are going to do, we have some challenges in our systems. What are they? Some of them are here. Security is a problem. Performance is another problem. Quality is another problem. What are they? For example, sparsity. If your data set is very empty, if there is not enough volume, it's just becoming very difficult to give you a recommendation. This is one of the biggest problem. Another one is cold start. For example, if you don't have any account, and if you just join, let's say Spotify, like your friend asked me, just join there, and when you just join to Spotify and ask, do you recommend me music? Who are you? What is your previous taste? Have you ever voted before? Did you like any music before? No, that's why I cannot recommend you anything. That's it, finish. We don't say that every system should recommend something. No, I can recommend you something that people likes, non-personalized. At the beginning I told you, but I cannot recommend you what you like because I don't know what you like. That's why for some systems, for the new systems, when you join for the first time, it is asking, if you face to that one, it is asking, please vote this music, that music, and that music, and that music. So then this way is just trying to get your taste for the very beginning. You are just voting a few of them. Some systems ask you 5 questions. Some systems ask you 10 questions. And the other one that I have to tell you is performance. For example, when you click data, recommend me something, and if it takes like more than 10 seconds to give you answer, so it's going to take time. We are just very quick people and fast people. We don't wait. And of course, it's the performance affected by the big data, lots of information in the data set. And security is important. Why? Especially nowadays, it's very important. GPDR, as you know, GDPR, not GPDR. Whatever. What is this? Privacy preserving. So then, for example, I may watch some movies which people shouldn't know what I am watching. You got my point. Or I may read some books which is just against to some thought, for example. So then that's why my privacy should be just preserved. So it's security. And I must trust the system when I vote it. Why? Because I know that that system is just protecting my privacy. You got my point, right? This is one of the important issue. Another one is shilling attack. The owner of the company should vote it's some item which he would like to sell more, for example, himself. Asking colleagues, please vote it to me for this item because I would like to make it in the top level, blah, blah, blah. So this is also another problem for the challenges. There are some other things as well. I'm just going to close up now, all of them. Let me just see the time. Yes, it's good. As I mentioned, like it's going to be around 1 hour. One more thing that at the moment I am busy with, maybe you have seen that already, some famous recommender systems is serendipity. In other words, is this way, because people just get used to the one who bought this book did buy that book as well, or the one who watched this movie did watch this movie as well, or because I know who you are, probably you will like this movie, or you are going to give vote to that movie, something like this. So then system is just giving you, and as a people, as a population, we expect from the system that is going to give the correct recommendation. Nowadays, the famous one is surprise me. Surprise me means like, I expect that you are going to give me a good recommendation, but surprise me. Tell me something different, because I may change my idea. So that's why just serendipity-oriented approach is starting nowadays. And maybe in the new area like Netflix, as I mentioned, Disney, maybe Spotify, these are the most famous ones, that's why I'm just saying them. You can see there's a button there. Recommend, okay, but surprise me, something different. Maybe if you like comedy movies a lot, but when you say surprise me, it's just giving you not comedy or comedy and action movie. Oh, I like that also. Or maybe you will not like, because at the end of the day, it's just serendipity. Okay, these are the basic stuff. I think that's all what I would like to mention, because my intention was just to give brief information about the recommender system, how is it used in the market industry, and it's just applicable everywhere, as you may know. And that's all for my presentation.